Hello again. This is an Algebra 1 video, and it's about exponent rules. The first page we have a product raised to a power. We're going to compare that to something that gets confused and mixed up a lot, which is a sum raised to a power. Totally different rule than this one. The second page we're going to multiply like bases. See that this is a really nice pattern to understand and to use. It's a nice shortcut. And then dividing like bases. Also very handy. Now, a product raised to a power. This AB is indicating that we're multiplying these two factors, A and B, whatever those are, could be any values, and then we're raising it to a power. So what we do here is we apply this degree n to A, so we get A to the nth power times B to the nth power. Alright, now in a situation like this where we have 2x raised to the third power, and now these parentheses are important because 2x to the third power without the parentheses is only applying the third power to x. In this situation we have to apply it to the 2 and to the x. So do pay attention to parentheses. What we end up with is 2 to the third times x to the third, and we can simplify that to 8x cubed. Okay, now the sum raised to a power, there's another video about multiplying polynomials. What we need to do in this case would be to expand and multiply a plus b times itself however many times this degree told us. So let's look at this as an example where we have a degree 3. We're raising 2 plus x to the third power. So if we expand this, we end up getting this product, which is certainly a more complicated and difficult process than applying this shortcut or this rule for a product raised to a power. So don't get a sum or some kind of polynomial anytime we have terms being added or subtracted that gives us a polynomial. In this case, a product is simply a monomial. Okay, this is a single term. No matter how many factors we have multiplying together in here, it still constitutes a single term, a monomial, and that's when you can apply this rule of a product raised to a power. Now on this page, we have our second rule, which is multiplying like bases. And the rule says when we multiply like bases, we add the exponents. This product would give us the base b to the power n plus m. And let's look at an example. What I'll do is I'll expand this and do it the long way, and then we'll compare it to this shortcut or this rule. So here it is expanded. 2 to the third expands to 2 times itself, right? 3 2's multiplied together. 2 to the sixth, 6 2's multiplied together. 1, 2, 3, 4, 5. Oh, uh-oh. One more. There we go. 6. And this is now completely commutative. We could put these in any order and multiply, right? All we're doing is multiplying a bunch of 2's together. But 2 times 2 is 4 times 2 is 8. And if we continued that here, 2 to the 6th is 64. 8 times 64 is 512. Now the alternate version, instead of expanding, would be to apply our multiplying like bases rule, which would give us 2 to the 3 plus 6 power, which is 2 to the 9th, and that should make sense because we had 9 2's lined up here to be multiplied. I don't know what that is. And 2 to the 9th, you can use your calculator to check, is 512. Now for dividing like bases. The rule is very similar to what we saw for multiplying like bases. When we have the same base, and I probably should have stressed that more on the last page, this has to be the same base. Like over here, we have base 3. Okay, that is essential to use this rule. What we do is get a quotient where we have that same base to the power of n minus m. So for dividing, that's an n. For dividing like bases, we subtract the exponents. And here we can expand. We'll do it the long way first. 3 to the 5th would be 5 3's multiplied together, divided by 2 3's being multiplied together. And if you'll remember something from pre-algebra, anytime we have common factors like this in numerator and denominator, those reduce to 1 over 1. These also reduce to 1 over 1. And we're left with a numerator of 3 times 3 times 3 over 1. And we don't need to write a denominator 1, but what is 3 to the 3rd power? 27. Now, had we used this property, or this shortcut, we would go right to the subtraction 5 minus 2 as our new exponent. 3 to the 5 minus 2 is 3 cubed, the same thing we ended up with here, and 3 cubed is 27. Thanks for watching. Keep practicing.